Hello, am I audible? My name is Ankur. I am a developer at ThoughtWorks. We are going to talk about Terraform. Before we go to Terraform, uh, I will ask some questions to you. So, let's say we have a typical web application, client server architecture application, and we have to deploy it in a multiple environments, right? We may have test environment, demo environment, and production environment, or many more. If we do it in an automated fashion and we do that in a manual fashion, right? Create every resource manually. Let's say there is one web server machine and two web service machine. There are three machines and two load balancers. If we have to do it in a manual way and in automated way, what can go wrong in the manual way? Our automated way will make what things easier. Anyone having any comments, any answers?
Might miss on one of other servers.
We might miss some of one of the configurations, right? Our servers. And that thing can be like consistency in name, right? If it is automated, whatever you provide in the code will go there. Otherwise, in manually we can put anything. We might not remember the name conventions later. So similar app, we will actually create using Terraform, deploy some small application on that, and see get a working app. Let's get into Terraform now. So this definition was taken from their website only. I couldn't find a better definition for this. Terraform is a tool for building, changing, and versioning infrastructure safely and efficiently. Uh, so what are Terraform provides, right? So Terraform provides a way to code your infrastructure itself. You can code your infrastructure, write variables, say whatever you want to create. Next thing is it supports multiple providers. So you can create many like resources for many providers using Terraform. Other thing is after writing the script, you can plan and see after running the scripts what is going to happen next, and then you can apply it. If the plan looks good, you can say apply. So those resources will be created. Terraform is quite easy to adopt as well. So these are few plans which will be mostly used by development of Terraform. Like when we use Terraform, right? These are the commands which we will be using mostly. So Terraform plan will show you the plan that after you apply, what actually you are going to modify, what resources you are going to create, what resources you are going to delete, and all this. Apply will actually apply the plan. So whatever plan said, apply will put those resources, modify those, delete those in your real physical world, real world actually. Destroy will destroy all the resources. Terraform maintain resources. So whatever resources Terraform is maintaining, destroy will just delete them. And output is a command which will only give you some values when you have already defined few output variables. How to define output variables? That will see in further slides. Correct. So these are the plans, right? These are the commands. Now, how does Terraform knows actually that what to do, what to create, what to modify, what to destroy? To do that, Terraform maintains a state file. So in state file in JSON structures, basically it will put all the resources with their attributes. So even if you modify something, that attribute will change. And plan will actually look at the state file. If the state file has that attribute and something is modified, it will say for this machine or for this resource, you are adding one more tag. You are renaming that machine. You are changing the VPC. And apply looks at the plan and does the same in the same way. And after apply only, actually your Terraform file will be edited. Otherwise, Terraform file is not modified. After apply only it is modified. Plan doesn't modify the state file. Output. So basically, when we define some output variables, those variables and values are also kept in the state file. So when we run Terraform output, basically those output variables are filtered from the state file and we can see them. Destroy works, whatever is maintained in the Terraform state file, destroy will just delete those resources. Looking at the state file itself. It is advisable to not manually edit the state file because let Terraform handle it. If you delete something, Terraform might not be able to function as expected. So there is a way to keep remote file in AWS S3 bucket as well. And basically on remote places, it supports Atlas as well. Because we are going to mostly discuss on AWS resources, I am showing a way to keep it in S3. Why this is useful? Where this is useful actually? So there will be a team which might be working on creation of infrastructure, creation of resources. If you are keeping in your local, you can create some other resource, and same resource your teammate might try to create, right? If it is on a common place, you can fetch actually same details. You can see what is there. You can see same plan. You can do same apply, right? So let's get into the code, right? How do we code in Terraform? Because Terraform supports multiple providers, the first thing you need to tell to Terraform is what is the provider, for which provider you want to create resources. So this is a way to tell how do I tell my provider is AWS. It can be Postgres, it can be Atlas, it can be Azure, any other thing. And there are few supported parameters which you need to pass. I have passed region. Other than that, it will need access key and secret key as well, which you can keep in your environment variable. So you don't need to actually pass it anywhere in your code. When you run Terraform from your machine, it will pick up directly. Next thing is to create resources, right? You are told what is provider. Now what resources you want to create. So the way to create resources is type resource. What resource you want to create? I want to create AWS instance. And like in other languages, right? We give a name to function or task. So this basically, if I will have to say this is a code, I will say this is a function. In the function you give a name, right? So you can see demo web service. That will be basically a name to that function. And then there are list of supported parameters which are supported by AWS instance. So like instance type, AMI, VPC ID, security groups, and other things, which you can find on Terraform documentation very easily for every resource. This is just to show how can we declare one resource, right? Next thing will be input variable, right? If you see here, I am hard coding the values, T2 micro, AMI IDs, and all these things. You might want to give a variable value and use that variable value later, right? So how do we declare it? By using variable block. There are three kinds of variables which are supported by Terraform. String is defined variable, so if you are creating a string value, you don't need to actually tell type. But if you are going to create a map or a list, you need to tell what is the type of variable, and then you can provide map or list accordingly. Now how can we use input variables? So if it is a string, you can directly say var at variable name. For list, you may want to see some index. You can just say var at variable name and the index. And for map, it is like same. You can tell the key of the map. Or if you want to put whole map, you don't need to mention index or key whatever. Other thing is there is a way to override variables, right? Terraform provides two ways. One way is while running the Terraform commands, right? Terraform plan, Terraform apply, Terraform other commands. You can say -var variable name, the variable you want to override, and give the new value. With new value you want the variable to overwritten with. So -var works well if you have to override only 2 or 3 values, right? There will be cases where your list of resources you will have to overwrite a lot of values. In those cases, you can use var file. So basically, in the variable file, you can tell what are the new values of variables you want to override it with. And while running the command, you will say -var file is the var file path. Var file should have .tfr extension. So This will be useful, right? When you can override variables. You have created resources. You have to deploy on multiple environment, right? So if you can override variable values, for dev you can have dev.tf was. For production you can have prod.tf was. And while running the command you can say this is my variable file. So you don't have to actually write resource code every time. It will take the right values if you provide right var files of course and create the resources for you. So you don't have to write the code again and again. It is easy. So when we create resources in Terraform, right? We would want few references to resources because we are creating using Terraform. It is dynamic. So in that case, we can refer to some attributes of those resources and get some values. Like you may want to know the IP of a machine. You may want to know the endpoint of a RDS server if you have created. For that, output variables are there. So output variables are only in place once the resource is created. Before that, you won't see anything. The way to use it is use output block in value tell what is the resource. What is the resource? I was telling right function name. We were giving demo web server. So you can use that, and there are few reference attributes which you can get back from an instance. So that will be private IP for like private IP, public IP, and ARN few other things for AWS instance. For RDS it will be different. So those things also you can look at the documentation that what can be referred from each type of resource. So to tell Terraform about your own AWS account, right, you will have to use access key and secret key. But it is good practice to use roles because in roles you can define what all power my Terraform has to create resources, right? It cannot create all the resources. You can say it should be able to create only AWS instance with this name. So those things you can define in role. If you are giving an access key and secret key, it has more access basically. It's a good practice to create it. And if you are using a role, this is the way you can run a Terraform command. So basically you give the role ARN and tell AWS Zoom and then Terraform command. So any questions so far? Yes. Yeah, that's what I'm going to look at. So the question was how do we like get these values to Ansible, right? So that we are going to get into. So Ansible has something called dynamic inventory. Using dynamic inventory, Ansible can fetch values based on few tag names, few attributes and basically of EC2 instances. There are two ready-made files. You can find them on Ansible documentation. The INI file, right, which holds the setting of EC2 instances. Settings like if you are trying to get IP of a machine, do you want to see public IP or private IP of that machine? And some other settings. You want to get the DNS or IP. And EC2.py is the actual file which holds the code, which knows how to fetch those values looking at the settings. Questions? Okay. So we'll now go to the code and we'll create these resources, right? One web server, two load balancer, and two web service. So I have written Terraform code already, but I'll just create those files in front of you and copy paste those codes so that it is easy to understand. Go by step by step. So first thing we need to provide is provider. So I'll create a file called provider.tf. By the way, we don't need to create so many files, right? The way Terraform works is in the directory we are going to create it. It will take, we are going to run Terraform. It will take all the .tf file, somehow put them in a single file and run it. So whether you create multiple files or single file doesn't make any difference. Only it will be easy for developers to look at later, right? If you have to find out the provider, you can go to provider.tf and look at it. So first thing was provider, second thing were resources. So in resources we were creating EC2 instances, right? We'll go there and These are EC2 instances. So one thing to note here will be uh, so one web server we create, right? And web service was two. So how do we create two web service with the same configuration? You have to just put a single simple parameter called count and provide the value of count. It will be able to create those machines, those many number of machines with the same configuration. Correct? Then you may want to log into that machine, right? Your Ansible may want to log into that machine. So you can provide a key to that while creating the machines. You can provide key name. So basically, your resources will be created with those keys. You can see key name, right? So I will put this code also there, maybe in the same file. Next thing is our load balancers, right? We need two load balancers. By the way, there are few things, right? You can see security group and subnets. These I am giving because there will be less details to tell, less details to code in the basic introduction. These things also you can create in Terraform. Oh, no, yeah. So I will take, maybe I should do Terraform plan once, right, to see what is there. So I had added two EC2 instances and one key, right? Let's see what Terraform plan tells. So it is telling that there will be one web server AWS instance created. Because there are two web service instances, it says that there are two web service instances will be created, and third one is a key file. So next thing we'll add is load balancer, right? So file called plb.tf and put the load balancer code over there. Let's run the plan again. So basically now we have all the resources needed for our the server app architecture I showed. So again, if we look at plan, right, it says one key will be created, two web services will be created, one web server instance will be created, and two load balancers will be created. This looks all right. We will now apply the changes. So basically, when we do apply, it will go and create all these, whatever it shows in plans, it will go and create all these machines.
Can you increase font of the
Yeah. Is it visible? So it is creating all the machines, all the resources is specified. Okay, so it says like all six resources have been added: two load balancer, one key, three AWS instances. Now next thing is to deploy our application on those, right? So for that I have already written in Ansible scripts. I will run those, and meanwhile we will look at Ansible scripts as well. First part is to download all the necessary softwares and tools on those machines. So just now I ran provisioning.yaml, right? And I am using dynamic inventory. Those files are there, ec2.ini and ec2.python. So if you look at provision.ini file, right, I am telling that my host is which has a tag name called functional context and which value is demo. So it will find out all the machines which has a tag called functional context with value demo, and run the role call command on that. Basically, whatever role you define, it will find for the machine based on the tag name and run the defined roles on those. And the way we define tags. So if you go to Terraform file, right? In the tags we are telling functional context is demo, right? So basically it is going to run the role on both of these machines, web server and web service both. Let it provision. And meanwhile we can look at the AWS resources which have been created, right? Using Terraform. So if I go to instances, it has two web service instances, one web server instance, and load balancer. There should be two load balancers. There are two load balancers created by Terraform. Cool. So provisioning done. We'll deploy the front end app, right, which we want to show the UI for. So if I go to deploy front end file, which I just now ran, this file says that run the role UI on the machine which has a name called web server. So I would have defined a tag in the web server with the name web server in Terraform. So if you go to Terraform, right, there is a tag for web server which has a name called web server. And I am using EC2 ELB fact. So basically the backend IP, right, the frontend has to make some request to backend. But because there are two machines of web service, I don't know where to make the request for. So in between there is a load balancer, right? So EC2 ELB facts given the name of the load balancer can fetch the load balancer details. So by doing that I am getting the load balancer's URL. So once this is done, we'll deploy actual backend and see the working app. So meanwhile this is being deployed, right? If anyone has any question regarding Terraform or Ansible, I can take those questions.
I have
Yeah.
So is there a concept of containers in Terraform? Like implementing containers?
So it is like Terraform, right? You can run from any machine, right? So if you can log into a container and you want to run it from there, you can run it from there. You can run it from your local machine or from AWS.
Like there is Kubernetes, which is like deploying your these all servers to a container. But are you like it's a container specific to containers? Is there a concept of containers in Terraform?
So you told deploying the apps on container, right?
Yes.
So Terraform is not supposed to deploy the application as well. It is supposed to create the machines you want. So whatever providers it supports, it will be able to create those resources for you.
Okay.
For deployment, that's why I'm using Ansible. So this is going to be my URL. Once the app is deployed, I hit there you are. So basically, it's a very simple app. As soon as I say this is below the table is a card detail, as soon as I say add a item to my cart, it makes a backend request to those two machines, and then gets other details from backend, and basically so makes a get API to see what is there in your cart. So you can add, like basically you got a working app using Terraform and Ansible together. Any questions? Any comments? Any feedbacks? Nothing. Nice audience. Thank you. Yeah, that's it. That's it I have.